This is Joe Mercado. The views and opinions that I'm going to speak about are my own. This is AlertWeave. It's my personal research platform. I built it because alert processing is repetitive. I wanted to try to solve alert processing. So you have two agents here, an alert agent and a chat agent. They're independent of each other. They serve different functions. Now, each agent has its own system prompt, its own features, its own command filters. So that way the alert agent can allow commands that the chat agent can't allow. So it's independent the way you can configure it. Those runbooks that you see there, they're very important because that's where you'll specify all the commands that you're going to use to process alerts. So on a per alert type, you specify the commands. In this case, I'm going to be running a BGP alert to the platform. The AI agent is going to pick it up. So I'm going to go to the actual switches that are running this BGP peering. I'm going to shut down interface 1. That's going to cause the BGP peer to go down. It's going to trigger an alert onto the platform. It's going to arrive via a webhook. So it hits an API gateway in AWS, and then it's ingested onto the platform. So here I'm showing the BGP peering is actually down now. The two alerts arrived. You can see here, they say investigating. Now I'm going to just click on one of them. And these alerts on average take anywhere from 30 seconds to a minute to process. It depends on what you define inside the runbook and how many commands you want to run. The more commands, the longer the alert will take. So every time an alert is done, this is how the alert will appear. There's a resolution summary, there's metadata, agent metrics. All this here is provided on a per alert basis. The report does not change. They always appear in this format. So as you can see here, resolution summary that's given is derived from the SSH commands that it ran. So it knows that Ethernet 1 was emissive shut, and that's why that BGP peer seems to have been down. These are the SSH commands that were defined in the BGP runbook. These commands were actually run on the device by the platform. So when the alert arrived, it knew it was a BGP alert and that it had to run these specific commands. And all of them were successful, because if they're not, it would have shown it there. Now, every alert that arrives gives you the ability to chat with it, chat with the device that sent in the alert. So here, what I'm going to do is I'm going to re-enable the interface so that the BGP peer reestablishes. And then once it reestablishes, we're going to ask the device that sent in the alert questions in natural language, and those questions will be converted into commands, as you're going to see here. This is the chat agent. The alert agent is the one that ingested the alert and processed it. This is the chat agent. As you can see, I asked it a question, check the BGP peer status. It issued two commands based on the resolution summary that we saw. Everything that is on this alert page was preloaded automatically into this chat window. So that way you don't have to copy and paste anything. You just ask it questions and it already knows that you're talking about the device that's listed, the 001 device. And it's converting these questions into commands. See here? It ran the command, gave you the output. This is all preloaded. And you could ask it anything. All commands that leave this platform onto the on-prem infrastructure, they pass through a safety policy engine. And it makes sure that those commands are approved. If they're not approved, they get stopped before they reach the on-prem infrastructure. So right now, every alert that gets processed, there's a notification that goes out. I'm going to show you the 3 different notification channels that we have enabled. One is email. The other one is Slack. And the same investigation summary you saw, the same detail you saw in the portal, the email, they're all the same. This is the human in the loop, simple human in the loop. There's a ServiceNow incident ticket that gets created as well. Show here. My goal with creating this platform was to resolve repetitive alert processing, at least the first 80% of it. Okay, so now that we know that the alert is resolved, we're going to rerun the AI agent against the alert, and it's going to check the alert to make sure that it's truly resolved, and then close the alarm and the monitoring platform that this came from. It could be any monitoring platform. So the commands that are in the BGP runbook are going to get rerun again on the device, and whatever's in that runbook, whatever criteria is set, we're going to make sure that it gets checked out. So in this case, it confirmed the BGP peer is back. It ran the same commands, the same 5 commands that you saw in the previous page. It ran the same commands, confirmed this back. Now, you can also chat, and you can also view different notification settings. So this is the notification settings that we showed, the email, Slack, and ServiceNow. There's other ones as you can see, but just showed you those 3. Now you can also chat with other devices. In the lab that I have at home, I only have these 2 devices, so I'm going to ask questions to only these 2 devices. But anything that you can SSH into, or even call APIs against, you can chat with. This doesn't do exclusively just SSH, it does API calls as well. In this case, I'm just showing SSH. So I'm going to ask it this question here, and it's going to check this out for me, and it's going to convert it all into commands. So you can ask it multi-nested questions, and it accepts them just fine. So here, it's logging into these 2 devices, it's running these 2 commands, and it's going to do the comparison for me. So that's the advantage of chat, that you can do investigations, you can check CVEs, you can do a lot of audits, a lot of audit work, and that's one of the benefits of having an LLM AI agent be part of your investigation process. So here I'm going to try to have it do something that's not allowed on the platform, and it's going to get caught before it reaches the on-prem infrastructure, because these commands that it's trying to execute, as you can see here, this is not allowed. So it's not going to be able to make it to on-prem infrastructure. It'll allow the show IP PIM, they'll show interface if1, but it's not going to allow the configuration commands that you saw. And it tells you here that it was blocked. So the platform is designed to only allow commands that are predefined and block anything that's destructive before it reaches the on-prem infrastructure. And this is designed architecturally to be legible, to be able to see everything that crosses from AWS to on-prem. Also, I'm going to show you that anything that comes back can also be redacted. So that way your traces are sanitized to the level that you want. So here we can see that we redacted this community. And you can do the same thing with passwords and certain things that are particular to you, you can redact it by design. Now, on the alerts page, I'm going to show you the alert that we resolved. And after this got resolved, there was an additional email that went out now that said this is resolved. As you can see here, same thing with the Slack message. There's a separate notification process that occurs. So just because the alert came in the first time doesn't mean that there won't be more notifications that go out. So every time something changes with the actual alert, there's a separate notification that goes out.